If you were living through the 1950s or 60s, the threat of nuclear war wasn't a movie plot. It was dinner table talk. Families practiced duck-and-cover drills, governments built fallout shelters, and suburban basements turned into makeshift survival bunkers, stocked with canned beans and Geiger counters. But behind the public displays of readiness, there was a lesser-known engineering trick developed during the Cold War that outperformed most of those expensive bunkers, and it's one that still holds value today. This wasn't about concrete or steel. It was about earth, air, and smart thermal design. And if you're into history, homesteading, or off-grid resilience, this Cold War shelter method might just be the most practical and overlooked survival tactic ever devised. So, before we jump into modern preppers' fascination with high-tech underground homes, let's rewind to a time when engineers had to rely on physics, not luxury, because that's where the real genius lies. When the Cold War was heating up, both the United States and the Soviet Union began experimenting with earth-sheltered structures, shelters built into or under the ground, using soil as a natural defense barrier. Unlike concrete bunkers, which trapped heat and required massive amounts of ventilation, these designs used the Earth's own stable temperature to regulate conditions inside. The soil, about 6 to 8 feet below the surface, maintains a fairly constant temperature year-round, usually between 50 and 60 degrees Fahrenheit or about 10 to 15 degrees Celsius, depending on your location. That meant an underground shelter didn't just protect against radiation. It also stayed naturally cool in the summer and warm in the winter. This simple principle, using soil as insulation and protection, was honestly one of the most effective passive survival strategies ever developed. Cold War-era field manuals, including those used by the U.S. Office of Civil Defense, described how to build semi-buried fallout shelters using logs, sandbags and dirt. These weren't the million-dollar bunkers you see in prepper documentaries. They were small, efficient, and built to be quickly concealed. The brilliance was in simplicity. A few feet of packed soil could reduce gamma radiation by up to 90%, and if you added a few more layers or a trench-like entryway, you could approach total protection. The problem with most modern bunkers isn't that they're unsafe. It's that they're unsustainable. Without powered air systems, they can quickly become deadly. Cold War engineers faced the same issue, but, they came up with a brilliant workaround. The earth tube ventilation system. Instead of using electric fans, they buried long pipes, often metal or ceramic, several feet underground, and connected them to the shelter interior. The pipes allowed cooler, denser air from outside to flow in naturally, while stale, warm air escaped through a higher vent on the opposite side. This created a constant natural airflow, known today as a thermal siphon. Modern homesteaders and off-grid builders still use this same system under the name earth tube cooling. You can apply it yourself by burying a 20 to 30 foot length of 4 to 6 inch pipe at a depth of at least 6 feet, running one end outside and one into your shelter, cellar or greenhouse. The air entering through that tube will always be closer to the Earth's temperature, cool in summer, mild in winter. It's not only effective but silent and maintenance-free, just as it was in the 1960s. Modern bunkers tend to focus on amenities, reinforced concrete, blast doors, solar lighting, but they often overlook long-term livability. An Earth-sheltered Cold War design, on the other hand, was built around sustainability. It was meant to protect you for weeks without reliance on power or supply chains. The Cold War's Kearney Fallout Shelter, which is detailed in the US government manual Nuclear War Survival Skills by Cresson H. Kearney, relied on really simple materials like sandbags, logs and plastic sheeting to create living quarters that were safe from radiation. Tests showed that when these shelters were built properly and ventilated well, they kept temperatures steady, the air breathable, and radiation exposure to a minimum, all without the need for electricity. This type of design wasn't just practical for a nuclear scenario, it's actually just as relevant today for people living in really extreme climates, or anyone who wants to build an off-grid root cellar, a storm shelter, or even an energy-efficient home. You can adapt the same idea by digging partially into a hillside or constructing a bermed structure where 3 sides are covered with soil. Add passive ventilation using earth tubes, maybe a small solar air pump if you want a bit of modernization, and a south-facing entrance for natural light and drainage. And you end up with a shelter that's comfortable, secure, and naturally regulated by the Earth itself. If you're keen to put this knowledge into practice, you don't have to go all in on bunker mode. You can absolutely start small. For instance, you might build a root cellar or a storm shelter that uses the same principles of thermal mass and ventilation. Just dig into a slope, or even a flat area, at least 6 feet deep. Line the walls with stone, clay or reinforced earth bags and top it off with logs or corrugated steel sheeting before you backfill. Make sure to include at least 1 air intake tube and 1 exhaust vent, spaced apart to create a bit of natural airflow. You'll quickly find that the temperature inside remains strikingly consistent even through the harshest seasonal swings. The same principle can also be used for long-term food storage, seed preservation, or emergency sheltering during extreme weather. In many ways, this Cold War approach reminds us that survival doesn't require a fortune. It requires, well, physics and patience. The people of that era didn't have access to advanced materials, but they understood nature's balance and how to work with it instead of against it. That's really what made their designs timeless. The Cold War left behind plenty of fear and political tension, but it also left a library of hard-earned wisdom. The Earth-sheltered shelter is one of its most underrated legacies, a testament to ingenuity under pressure. While modern technology keeps evolving, the simple principles of thermal mass, radiation shielding and passive airflow remain unbeatable in terms of cost and reliability. If you ever study survival design, urban planning or homesteading history, this is the trick worth mastering. Forget the fantasy of high-tech bunkers. This is the kind of shelter that worked when the world truly thought it might end. So, if you found this dive into Cold War engineering useful, make sure to hit subscribe, share this with a fellow history buff or prepper, and keep exploring the lessons the past still has to teach us. Because sometimes the smartest solutions are buried just beneath our feet.